Okay, so my vertex here, negative b over 2a, that's negative, and then 4 over 2 times negative 1. Sorry. Negative 4 over 2 times negative 1 is going to give me a positive 2. So my vertex for this one's going to be 2. When I plug that in, negative 2 squared plus 4 times 2 plus 2, it's 2 squared, it's 4, and then the negative is applied. So negative 4 plus 8 plus 2 gives me 6. So my vertex is 2, 6. 2, 1, 2, 3, 4, 5, 6. If I plug 0 in for x, I get y is 2, and then over 2, over another 2, 4, 2 are my points. Now the bottom one, I'm going to do my negative b over 2a again. Negative 4 over 2 times 1. That's a positive 2. 2 squared minus 4 times 2 plus 10. We have 4 minus 8 plus 10, and that equals 6. So my vertex for this one is also 2, 6. If I plug 0 in for x, I get 10 over 2 over another 2. So there's my one parabola. Here's my next parabola. I don't need to worry about where they intersect. They intersect at one point, at that vertex point, which is 2, 6. Now, if I were to do this one algebraically, you set them equal to each other. I'm going to add x squared to the right side because I want the x squared to be positive. I'm going to subtract 4x over, and I'm going to get negative 8x. I'm going to subtract 2 over, and I'm going to get 8. I'm going to take a GCF out. I'm going to take a 2 out. And when I factor it, I'm left with x minus 2 times x minus 2, which is x minus 2 squared. Therefore, my x has to equal 2. When I plug that back into an original, which is what we kind of did trying to find the vertex anyway, my y equals 6. So once again, this is a case where you're only going to get one answer. Okay, that can happen because they intersect at the vertex. Next one here. Negative b over 2a. That's 2 over 2 times 1. So it's a negative 1 for the x coordinate of my vertex. I plug that in. Negative 1 squared plus 2 times negative 1 minus e. Negative 1 squared in this case. And the difference is the negative 1 is the actual value of x. So that's what I'm plugging in for x. That's why the negative gets applied to the squared here, but not in the previous problem. Negative 1 squared is 1. 2 times negative 1 is negative 2. So that's negative 1 minus e. We get a negative 9. So there's my vertex. Negative 1. Negative 9. And I know 0, negative 8, and 2, negative 8 are going to be points as well. 0, negative 8, negative 2, negative 8. Down here, negative b over 2a, negative 2 times 2, negative 1, that's going to be a positive 1. My vertex here is going to be 1. I plug that in. Now notice I'm plugging, be real clear about this, 1 in for x. So that means the negative's on the outside here. This is not plugging negative 1 in for x, where in the top one the square applies to the negative. Here we square the 1, then apply the negative. Order doesn't matter. We end up with an answer of 1 here as well. So my vertex is 1, 1. Not a different color of 1, 1. And then those points are going to be 0, 0, and 2, 0. So extra points, 0, 0, and 2, 0. So you can start to see where these parabolas are coming from. One's going up this way, one's going down this way. Okay? In terms of trying to figure out their points of intersection, my advice is this. The points of intersection are going to come through this way and this way. So I'd start by putting -1 in both of them. Okay. If I plug -1 into the top one, -1 squared is 1. 2 times -1 is -2. 1 and -2 is -1. -1 minus 8 is -9. So that's the vertex down this one. Now let's try the -1 in for the bottom one. -1 squared is +1, so now a negative gets applied, -1. 2 times -1 is -2. -1 and -2 is -3. So -1, -3 is my point. Let's keep going. Let's try -2 here. -2 squared, and we can just do the bottom one now. -2 squared is 4, and that's a -4. 2 times -2 is -4, -4, -4 is -8. So when I plug -2 in, I get -8. 1, 2, 3, 4, 5, 6, 7. And there's my point of intersection. Okay. So my advice is, you know this one's going up, this one's going down. Let's keep going to the left to see if we can find a point of intersection. Okay. Now, with the red one, 0 is -8. Let's plug 1 in. 1 squared is 1, plus 2 times 1 is 2. 1 and 2 is 3. 3 minus 8 is -5. So when I plug 1 in, I get a -5. Let's plug 2 in. 2 squared is 4. 2 times 2 is 4. 4 plus 4 is 8. 8 minus 8 is 0. There's my second point of intersection. So my answers are going to be -2 and -8. 2 and 0. And then I'll draw my parabolas as sketches. And that's where they intersect with those 2 points. Here's the work to find those points. So if I use the black graph to start, I got 2, 0, 0, 0, and 1, 1. I need to come to the left to go over that point of intersection. So I'm going to write now, plug -1 in for x. -1 squared minus 2 times -1. Oops, plus 2. -1. That's going to be a -1 minus 2. That's -3. So -1, -3 is a point on my graph. That doesn't hit the other graph, but that's not the point of that intersection. So let's try -2. Okay. -2 squared is 4. -4. 2 times -2 is -4. We get -8. So in that case, when I plug x's for -2, we get to my -8. That's that point of intersection. For the red graph, as I'm going up, I know I'm at 1, -9, -2, -8, and 0, -8. I need to keep going to the right to find that next point of intersection. Plug 1 in for your equation. 1 squared plus 2 times 1 minus 8, that's -5. That doesn't hit the black graph, so let's do this one. 2 squared times, or plus 4 times 2 minus 8, that equals 0. That gets me to my point 2, 0. That's my second point of intersection. The algebraic version is this. -x squared plus 2x equals x squared plus 2x minus 8. And watch what happens. I'm going to add x squared to both sides and get 2x squared. Subtract 2x on both sides. I get 0. And then I have my minus e. If I were to take a 2 out, I'm left with x squared minus 4, which is the difference of two squares. That factors to x minus 2x plus 2. So my answers are going to be my x equals 2 or negative 2. If I plug that back into an original, when my x equals 2, 2 squared is 4, it's negative 4, plus 2 times 2 is 4, negative 4 and 4 is 0. When my x is a negative 2, negative 2 squared is 4, we apply the negative, negative 4, 2 times negative 2 is negative 4, negative 4, negative 4 is negative 8. You should get the same answer.